Hi everyone, welcome to our session, Surprise Me, Creating Advanced and Unique Charts in Tableau. Wow, this is really huge. Thank you for attending our session. I'm Klaus, I'm from Germany. I'm a professor of management accounting at Münster University of Applied Science, and I'm a 2019 Tableau Zen Master. Are there any accountants here around? Please wave your hands. Okay, yeah, we guys rock, thank you. Okay, so what are we going to talk about today? We want to talk about the Viz that some of you might have already seen in the Viz gallery, our collaboration on the former tennis hero Boris Becker. We want to talk a little bit about the Viz itself, but also about the evolution of the Viz, and most of all about the techniques we have applied to create it. And therefore, I'm very, very happy to have my good friend Ludovic with me here on stage. He will share his techniques, I will share my techniques, and our goal is to enable you to create custom visualizations by yourself. Ludovic.
Okay, thank you, Klaus. Hi, everyone. I'm Ludovic. Well, we are a few, yes. Thank you for coming. And Klaus and I are very glad to meet all of you and to share with you our most precious techniques. But get ready, because it's going to be hard, it's going to be tough. But by the end of the session, you will live in a whole new Tableau world.
Okay, so let's start. Let's start about and talk about the Viz that we have created first. The idea to do a collaboration on this topic, on tennis hero Boris Becker, was born at TC in New Orleans last year. You know, Tableau conferences are the best place to create new ideas and to learn to know new people and to think about collaborations, and that's what we did in New Orleans too. And then we basically decided to do this Viz on Boris Becker for two reasons. The first reason was we are both big fans of Chris DiMartini's NBA playoff Viz from last year. Chris did a fantastic job, and he created a tournament tree and had multiple layers, and we wanted to create something similar. The second reason was we wanted to focus on the story or scrolly telling, so we wanted to do some kind of data essay to talk about Boris Becker and his career back in the 80s, sorry. And therefore I could make some contributions because I was a child when Boris Becker did his first major win in Wimbledon. So I have very good memories about this time when Boris appeared from nowhere.
I'm too young, I think.
Yeah.
I have no memories of that.
No problem.
Sorry, Klaus.
So maybe not all of you have seen the Viz already. You can see it in the Viz gallery, but maybe we show you a little bit of the Viz first. So this is the Viz, and for our Viz, we chose something like an inductive setup. So we are starting with a single match, a single crucial match. Oh, this is slow.
Can I?
Yeah, please. With a single crucial match from the Wimbledon 1985 tournament. And this was Boris Becker's third round match against Tim Mayotte. And in this step line chart, we visualize every point played in this game. We also use momentum dots to show the ups and downs in this match. There was a time in the first and the second set when Tim Mayotte was looking very strong, but then eventually Boris recovered and won the fifth set with 6-2 and the match.
Bravo, Boris. After that, we wanted to visualize the match inside the tournament it took place, so we built an horizontal tournament tree chart where we can see, of course, every match and with every player in it, with the score, and in red, of course, the path of Boris Becker until his victory. Finally, we went a bit crazy because we decided to visualize Boris Becker rise into all tournaments he played in. So we built this a vertical bump chart on top of the horizontal tournament charts. So we visualize rise of Boris Becker from 1985 to 19 89 in this visualization.
Yeah, and my favorite feature, Ludovic, maybe you can show it, is we implemented set actions to compare Boris' career to the one of his major to his major colleagues from the ATP tour. The purple one, for example, is Ivan Lendl. He won a lot in the 80s. Now we can see Mats Wieland, I think, in a dark green color. He won almost everything in the 80s. And this was, I think, a very, very good decision to visualize it this way, to have all the data in it, but also interactivity and flexibility to compare Boris' results to others. Yeah, so this was our Viz, or this is our Viz. You can find it on Tableau Public, and feel free to download it and to reverse engineer it. So for this Viz, and maybe let's talk a little bit about the data for this Viz, we needed two different kinds of data. For the first part, for the step line chart, we needed match data for the match Boris Becker against Tim Mayotte. And you guessed it, the data was not available. For some projects, for really special projects, yeah, you might have to go an extra mile, and that's what I did here too. I was lucky that the game was available on YouTube, and so I watched the 3.5-hour match again and captured every single point. Yeah, sounds maybe a little bit nerdy.
Such a nerd, yes. That's crazy, man.
For the second part, for the tournament flow and for the bump trees, we were lucky. We could build on a huge database that we found on GitHub by Jeff Sackman. And we took this database, or in this database, we have all results from the ATP Tour since 1968, yeah, for every single match played. And so we could focus on the matches we wanted to focus on with Boris Becker. And in the first step, we created a fully functional and generic tournament tree. You can see it here on the right side. This tournament tree works for all single elimination and exponential structured tournaments. As you can see here, for example, we have different draw sizes from 16, 32, 64, 128. And we can now, with the math we have created, visualize every tournament in this structure. Yeah, and that was quite fun, as you can imagine.
So much fun, guys. You can't imagine.
Yeah, we shared the math in a blog post, so again, feel free to take it and to build own tournament flows.
Okay. After that, we wanted to go one step further, so we try a few experimentation, like this beautiful radial ball-like chart. And one day, I sent this beautiful paint picture to Klaus on Twitter, and I said to him, in my dreams, I want to try bump chart, tourney chart combo. And yet, that's very sad. I dream about visualizations. I dream about Tableau. And I think I'm not the only one in the room. I think you do too.
Yeah. Okay.
And believe it or not, you already know, we did it. Because, in fact, we can build anything we want in Tableau.
Okay, so how to approach such custom visualizations? We have seen in the last sessions here, or in many sessions, the famous show me. And guess what? You don't find tournament flow bump tree combos in show me.
Fortunately.
Yeah, and that's of course not the purpose of show me. So you can build quickly standard visualizations to make effective visualizations. But we wanted to do something different. We wanted to do a custom visualization. We both have done it before, I would say. We have competed both in Iron Viz finals in last year. And as I said before, today we want to share the techniques to create such custom visualizations. I, for example, did this Viz on the left side last year at TC Europe in London. I created trapezium tile map for Europe. And yeah, the technique I've applied to create this map, I would call it maybe drawing with numbers or advanced scatter plots. And I will going to explain this to you. Yeah, how to draw in Tableau, how to connect points, how to make it pretty. And I will explain also that most of the custom visualizations around are nothing more like scatter plots.
Okay, yes. And I created this multi-layered radial chart, and I will explain to you how to build this kind of thing using geometric functions, layers, data densification, nerdy stuff, you will see.
Okay, all right, so that's the agenda, and let's dig into it. And let's start with the techniques. I first would like to talk a little bit about this Tableau is a data-driven drawing tool, mantra or statement. I'm quoting here Jonathan Drummey. He's a grandmaster of Tableau and a Zen Master Hall of Famer, and I really recommend to visit his blog, Drawing with Numbers. He has written about so much stuff of Tableau. It's incredible. I could have also quoted many others. Would have been clever probably to quote someone here from the front row. I see Yvette Kovac, I see Neil Richards, Ann Jackson. Many have written about this, this technique. So what is it all about? Drawing with numbers is nothing more like a basic principle of data viz. We draw pictures by using data. And I want to explain this technique or this approach by using the coordinator tool. The coordinator tool is a tool that I came across some weeks ago in a tweet by fellow community member Zach Bowders. Hello, Zach.
Hi, Zach. In the US.
Zach uses this tool to create awesome visualizations on his favorite topic, on some superhero-related stuff. Okay, I know Batman, but not much more about this. So what does this tool do? I would like to demonstrate this to you with this Tableau logo. So I uploaded a file to the coordinator tool, and you see the tool processes this picture, and it gives you back little dots and the coordinates to these dots. Then you can download a CSV file. Yeah, you see it here in the middle. We have an X and a Y, and you then have to add manually a point order to tell Tableau how to connect the points, and another column to identify the different objects in your image. I've called it element here. And then you're ready to viz. Yeah, for some reason the tool didn't give me out all dots, so I had to add some manually, but that wasn't a big deal. So I have now X on columns, Y on rows. I have my I have my elements on details. And when I now change to the line mark and have my path on path, then you can create little pictures. We all know this logo, more familiar maybe as a filled object using the polygon mark. Yeah, this is drawing with numbers. We have coordinates, we connect the points, we format it, and we are ready to go. Let me show you a second example. Who knows this guy? I see him sitting in the front row. Merlin, hi. Merlin is a fellow Zen master from the Netherlands, and he has created some awesome stuff with extensions lately. And you absolutely have to make sure to attend his session tomorrow. There will be a great exposure with a new extension online multiplayer game. So yeah, when we found out that, at the beginning of the year, we found out that we live only some 20 minutes away from each other. And yeah, I was going to visit him, and I really liked the idea to bring data as a present. So
Such a nerd.
Yeah, okay.
That's great.
Yeah, so when I'm visiting fellow community members, I always bring data, and we do a VIST together. So did I with Merlin. And in my imagination, the Dutch guys always look a little bit like this. So they are crazy with football, and so I had the idea to create something football related. And then I was searching the internet, and I found this. Yeah, this is something like a breakfast plate, and on this breakfast plate we have a visualization of famous football goals from football history. Yeah, and here we see the winner of the 2014 World Cup final from Mario Götze. So I wanted to create the same thing for Merlin, and so I informed myself. Then a famous goal from the Dutch football history came to my mind, And this was this absolute stunner goal from Marco van Basten from 1988. Some of you might know it, one of the best goals that has ever been shot. So I wanted to create this breakfast plate for Merlin, and therefore I informed myself about the distances on a football field and the different objects. We have a penalty box, we have the circles, we have the goal, and so on and so on. And created the data in an Excel file, just quickly putting it down, and then started to create the Viz. So I have again my coordinates. I'm putting X on columns as a dimension. I have Y on rows as a dimension. Then I identify the different objects in my Viz with my element, or it is called path here, dimension. I'm changing the mark type to the line mark, and adding the point order to say Tableau how to connect the points. Yeah, I'm literally drawing with numbers here. You maybe see one aspect is missing. I don't have the circles here in my data, so I had to calculate them in Tableau, and I'm creating a second X and a second Y, and I'm dropping this second X and the second Y on top of the first ones, and then you can see how the circles appear and the Viz is done. So we have our soccer field, and the last thing left to do was a little bit of formatting, some labels, some text, and Merlin had his breakfast plate, and we had really fun to put this together in Oldenzaal. Yeah? So this was the first technique.
Thank you.
Thank you. This was the first technique I wanted to show to you. The second is the everything is a scatterplot mantra. Again, I'm quoting here people from the Tableau community, Alan Walker, Joe Mako, Roddy Zakovic, all former Tableau Zen masters and absolutely Tableau superstars, and they have written about this stuff a lot. So what is this thing with this mantra? You all know how to create scatter plots. We have seen it just some seconds ago. We're putting a measure, a continuous measure or a dimension on X and one on Y, and we have a scatter plot. When you want to do custom visualizations, you want to integrate more dimensions into your measures, into these measures that form the scatter plot. And one important thing to create custom visualizations is to be aware that you have to mind the dividers. I will explain this to you in just a second. So we want to mind dividers. We want to integrate dimensions into our scatterplot measures, and I will show you how to do this. First step, I would like to show you how where we have scatter plots in our Becker Viz. Yeah, you remember we had the step line chart. Of course, this is not a scatter plot, but we have the tournament tree and the bump flow, and there we have several dimensions included. Here you can see on the right side the path, how to create this tournament flow, and how we integrated the dimensions, match number, player ID, position type.
Scary.
Yeah, scary. For the bump tree, we had also to integrate the respective tournaments, so the Wimbledon 1985, US Open 1985, and so on. So there we have scatter plots in the Becker Viz. Yeah, so why mind the divider? What does this mean? Again, we know two continuous measures or dimensions on rows and columns, and we want to integrate further dimensions. Yeah, some time ago, I was also dreaming of a Viz.
I'm sure you did.
Yeah, I wanted to create a hex map and integrate little spark lines or spark bars. Yeah, you all know hex maps, for example, for the US, very, very popular. And most of the time, you lay a measure on color to visualize the different hex shapes. And as I said, I wanted to integrate spark bars, spark lines, and therefore I applied this technique, the everything is a scatterplot mantra. So this was actually data from a Makeover Monday project on minimum wages in the US. And I want to show you now, in the first step, my first attempt to create this. Yeah, there was a year field in the data, and I had my measure that I wanted to visualize. I put the states on details, and then I connected to a secondary data source. I bring in columns on columns and rows on rows to form the shape of the US. And this, you can see how the US shape appears. Now, I've talked about mind the divider. I let the dividers pop out here really, really clearly. And the dividers, they form some kind of grid. But these are not grid lines. Yeah, we also have grid lines in Tableau, and I would say they are the good ones. The divider grids, they are the bad ones. Because when you now want to create a custom visualization, yeah, like I have to add a hex shape to do my idea of a combo of lines and hex shapes, I would have to leave the cells. In a hex map, we have overlapping areas. We don't stay in one column. We don't stay in one row. And you can't leave the cells of this divider grid. Yeah? All the objects are captured in this grid. So the next step, in the next step, I will show you how to deal with this and to get rid of this grid. Yeah? And therefore, I'm now integrating my dimensions, columns and rows. These are the coordinates for the US form, for the US shape. I'm integrating these into my measures, into X and into Y. So I'm creating calculated fields and I'm bringing the X on columns. Here I'm creating now the Y field using my measure and the rows dimension. And I'm also adding 2 parameters to play with the positioning. As you can see now, again, the shape of the US appears. I'm having both measures on rows and columns. Now I bring the states to detail. And when I now change the parameters a little bit, I can put some space between the lines. And when I change the Y parameter, I can vary the scale of my line charts a little bit and make it look pretty. Yeah, so now I'm again formatting my dividers. So again, make it really, really thick and make it black for the row dividers and the same for the column dividers. Yeah, make them big and make them really black. And you see the grid has gone. We have integrated the dimensions into our measures, and we don't have this grid anymore. And that is what we also dream of. Yeah? Yeah. So we are now fully flexible in this cell. We can do whatever we want. We can connect points. We can work with shapes and do amazing stuff. And I, for example, used this technique in one of my last visualizations on the Earth overshoot day. This was an entry for the Iron Viz feeder here in Europe. And the object you can see in the center, the map is a world time map. Using this technique with little spark bars, visualizing the change of the Earth overshoot day in the countries. And the dots are representing the carbon footprint of the countries. And so you can create such visualizations.
Awesome.
Okay, so.
Awesome, Klaus. Thank you, Klaus. Yeah. It is really game changer, as you can see. Once you know how to draw in Tableau, a thing you want to do is to give sometimes a curvy aspect to your design. And guess what? You can use any type of curve you desire in Tableau. And I'm quoting Ken Flerledge here. Please, I beg you, if you do not go the guy, follow him, go on his blog. He already writes a lot about the thing we are talking about. He's awesome. So, what I mean by that? Let me show you in the Becker visualization. In the Becker visualization, I have 2 kinds of curves. I have a first curve for the horizontal tournament flow. I will use a function called sigmoid, and I have a second curve. It's for the bump chart. I will use the function logit. Actually, it is done thanks to extra points, as you can see here. And I will add those points thanks to a technique called data densification. I know it's a big word, but you will see. Okay, let's talk First, about data densification. It's a good start. So basically, what is data densification? You have one point, and you want to display a new visualization with several points. For example, a shape, like a rectangle, so you need 4 points, or a curve, you need multiple points. So how you can add those extra points? So there is basically two techniques. The one I use the most is using a secondary dataset. So what I mean by that is I have my main dataset with a fully aggregated measure in it, and I will perform a Cartesian product with what I call a model dataset with as many rows I want to use in my design. For example, for the rectangle, I need 4 more points. So now, for every row in my main dataset, I have 4 more rows to perform my design for the rectangle case. Okay, the other technique is using range and bins, and it's even more nerdy. I won't talk about it here, but I invite you.
Please
no,
do.
I can't. You will leave the room if I begin to speak about it. But I invite you to follow some blog posts about it. There is a lot of discussion about it already. Okay. Now, I want to draw a curve. I'm not the first one to try to do that. So on the left, you have Chris de Martini example, who he already tried to draw some very famous curve expressions. And I invite you to go also on Jeffrey Schaeffer blog, who already talked about curves and which curve is best to use in our well-known Sankey diagram. But let's back to business. So how to draw a curve? So first step, obviously, you have to find the curve you want to draw that best fits your design. For example, in the Becker visualization, I know what I wanted to do. So I needed to use the sigmoid function. It's very well known in our Tableau community to draw the tournament flow, and another function called logit to draw the bump chart. Actually, logit, it's only the inverse function of sigmoid, because one is horizontal, the other one is vertical. Next, you are here. Next, you have to modify the range of your extra points. What I mean by that is, as you can see, sigmoid and logit are not working within the same range. Sigmoid is working between -6 and 6, and logit is working well between 0 and 1. So you need to fix that before. Then you have to write this function in Tableau. It's not the most difficult part because, as you can see, both of the functions are not really difficult. And finally, you have to adapt, of course, to best fit to your design the function and use, for example, line mark type with the right path. Okay. I will show you an example of how to draw this kind of curvy aspect later, but first I will let Klaus give you an example of data densification.
Yeah, so thank you, Ludovic, for introducing these techniques. So data densification and curvy aspects, or drawing a curve. And I want to show you now an example. And again, I dreamed about Viz, and I wanted to create something that isn't available in the default in Tableau, and this is a step area chart. We all know, and probably we all love, the step line function. I think it was in the release 2018-1, something like that. Yeah, with this step line type, we can create these step lines. Yeah, okay, that's clear. So I wanted to create a step area chart, again in a Makeover Monday project, a sad one on rhino poaching. But what I want to do now is to show you how to create such a step area chart by applying the techniques that Ludovic just talked about. By the way, this little project taught me something about the line and the area mark. And I've put them here on the slide on the left side, and you will notice the small difference between those two marks.
Oh, it's path.
Yeah, it's path. Very good, Ludovic. Yeah, path is missing for the area mark. That means for the line mark type, we can define an order to connect points, but we cannot do this for the area mark. That means for the area mark, the points are connected from the left to the right, and you can do nothing about it. So with the path card missing, we also don't have the option of a step area mark, so or I had to become a little bit creative, and I will show you now how I did this. So I'm connected to Superstore data. I already filtered the data down to 1 year, to 2018, and I'm hiding my fields that I don't need. So yeah, again, I'm showing you the problem. I bring out order dates on columns. I make it a continuous month, and I have my sales. Okay, a pretty nice line chart. We have $733,000 sales in the view, and we have 12 marks, one for each month. Now I can here use path to create a step line chart. And you will see it when I change now the mark type to area, it is gone. So no steps left, just a normal area chart. So how can I do this now? So the step area option is not available, therefore I had to apply the technique data densification. And I had to do it in the simplest way by just bringing in orders one more time. Very, very easy in Tableau, just dragging it on again. And when you now see we have a dimension table name, I hope it is, yeah, and we have now the orders 2 times in the view. Yeah, and when I'm switching back to my sheet 1, you see the sales have doubled. We are at 1,466,000. But still 12 marks in the view, because Tableau is aggregating over the same month in this case. So how can you create a step area chart now? I, again, apply the technique of everything is a scatter plot. And I created this little field based on the table name dimension, and I'm using a parameter to separate the 2 copies of the data. I'm saying when we have the first copy, it is called orders, then take the month of the order date and subtract the parameter. And when we have the second copy of the data, I'm saying take the month and add the parameter. So this gives us a new measure, and I'm putting this on columns. And when I now drag on sales, I'm sorry, I have to change it here to a dimension. You already see we have 24 marks. Yeah, and I have the parameter at 0.25, so it is already getting a little bit steppish. And my first initial idea was, okay, let's change the parameter to 0.5, and there should be a step line chart. But look what happens, the steps have gone. Now we have only 13 marks in the view. Why is this? Tableau is again aggregating over same dimensions. And when we have 1 month plus 0.5 and the next month minus 0.5, yeah, we have the same measure. And about this I was thinking a little bit, and then I had the idea to change this parameter just a tiny little bit to yeah, outsmart Tableau and make it not aggregating over the same number. So I changed the parameter just a little bit, and you can see I have my 24 marks back. And when I now change the mark type to area, you see, boom, there is our step area chart.
Awesome.
Yeah, so data densification. Data densification, very, very helpful method to create such things. And now Ludovic is back on the mic and will show you some really awesome stuff.
Are you sure? Too much pressure. Okay. Let's get back to business. Okay. I will talk to you now about layering. So I'm quoting Chris de Martini here. He said that layering is building a number of visualizations, separate visualizations, and then overlaying them. So in our Becker visualization, we use that technique, of course, with our two different charts. So one layer for the tournament flow, again, and one other layer for the bump flow. Thanks to that, we are able to compute the x and y separately and then overlap both of the visualizations on top of each other. Okay, so now, how does it work? So layers. Basically, you have one point and you want to have another point overlapping over it. It can be at a different position, or you can have two different visualizations overlapped, like the rectangle and the curved one, up on top of each other. So how you to add those layers? It's the main idea than before. You have to duplicate your data, so you have to perform a Cartesian product between a main dataset, an aggregated one, and what I call a layer dataset that hosts as many layers as you need. Like in my example, with the rectangle and the curve, I need 2 extra layers. But what is really getting really fun when you use both extra points and layers, because you can draw things like that, rectangle and curve, but things much more complicated, like the Becker visualization or this multi-layered radial chart I built last year for Iron Viz. And I will explain to you how I built that. I did not use 2 layers, but 4 layers that are overlapped on top of each other to create the multi-radial chart. Okay, there we go. So I want to achieve this visualization, this multi-layered radial chart. I have a main dataset, aggregated daily, and some weather data like precipitation, wind, temperature. I will do a Cartesian product with a model dataset where I have both layers and extra points. I did that because I did not need to have 2 more datasets, but here's what we have: layers, 4 layers, and some extra points. I first need to use a geometric function to make basic circle, like here, with cosinus and sinus. It will be useful for after. And I built my first layer. My first layer is a radial bar chart. I need 2 extra points for this layer, data densification, one for the top, one for the bottom of my bar. It's that for layer 1. I will build a layer 2. I need 1 extra point, so no more extra point in reality, to build this one. As you can see in my model for wind, I only have 1 extra point. For precipitation, I have 2. Temperature, it's kind of the same, layer 3. 2 extra points to build this radial bar chart. And the last but not the least, the reference line is kind of more complicated, but same idea. I have 6 extra points for this one. So data densification again in layer 0 to build the reference line. As you can see, 6 extra points for layer 0. And now we can begin to overlap those visualizations. So I have layer 0, I add layer 1. Okay, now I have layer 1. I will add layer 2 on top of it. So I have now 3 layers on top of each other. And finally, 4 layers to build a multi-layered radial chart in Tableau. So we use... Thank you, Klaus. We are using data densification, geometric functions, and layers to achieve that. Thank you.
Can you believe that he has created this visualization in 20 minutes on stage in Las Vegas, in New Orleans, and that was really incredible, Ludovic.
Thank you, Klaus. Yes, thank you. Okay. One last for...
Okay, we have some minutes left. Okay.
Okay, 5 minutes. So let's talk about another stuff I did. So it's created a curved gradient area chart. It's not about the chart itself, but how I applied the techniques we see before to do something new. So I use here data densification, geometric function, we can already see the sigmoid, and what I call polygon stacking. Okay, I use it in a Game of Thrones visualization where I visualized word occurrence in by episodes with some popular word, as you can see, like fuck, like Kingslayer, wall, wedding, no spoilers, but that's pretty much it. Okay, so I will show you how I did that in a live demo. Okay, here I have my gradient with some values. So I use the scatter plot, everything scatter plot technique, and here in color I have something called stack. If I turn it discrete, I can see I'm just polygons that are stacked on top of each other to build this gradient, as you can see. Okay, I can reduce it to 2 to make it more clear. Okay, here I have 2 value in my stack, so I have only 2 polygons to build the gradient. Of course, it's not enough, but you see the main idea. Okay, so I have a main data set. You remember about this one. So I have a current value inside, so for some month, and the value after. It will be useful to calculate the curvy aspect. I have a model data set where I have the extra points I will use for the curvy aspect from 1 to 49. I have to fix the range, if you remember well, to use my sigmoid function. So now I have my extra points between -6 and 6. I use it in my sigmoid function. It's very complicated, as you can see. And I have the value for my sigmoid. Next, I use another dataset to say to Tableau, hey, you have to use those extra points on the bottom or the top. It will be useful for the polygons. And last but not the least, I have a stack dataset for the 100. Here I filter on only the 2 first. And I have to calculate, so be prepared. I have to calculate the minimum value that will appear in that stack and the maximum value that will be available in that stack. So here I have 2 stacks only. So my maximum value for my value current is 9. I need to say, hey, Tableau, the polygons are, first one is between 0 and 4.5, and the next one would be minimum between 4.5 and 9. I think I lost you, but that's not an issue. Okay. So let's get real. Let's get it real. So I calculate my x-axis. It's almost finished here using my fixed range and another thing. I calculate my y, sorry, French, my y value. I use my next value and current value to do that with the sigmoid value I calculated before. And why I did that, it's the first step to my Viz. It's just for having this curvy aspect. This is the first step, guys. Okay, now the fun continues because I have to use my stacks. And I have to say to Tableau, hey, Tableau, sometimes you have to use the minimum value of the stack or the maximum value of the stack, or if the y value I calculate here is below the bottom or top value, you use that instead. So I do it for the 2, I can do it for the 100. Okay, here are the functions. So just minimum between stack bottom and y. Okay. Pretty nerdy. Okay, now I have everything I need to build what I want to build. So I just have to add my x value. I will use this calculation where I said use my position dataset, where I say, hey, it's 0, so you have to go on top, or either you have to go on bottom. Just that. I use that. Okay. Here we go. It's almost that, but not clear. You have to use stack in color. Oh, I have my 100. That will be scary. Okay, let's get back to 2. So with 2 stacks, I have this. It's becoming more and more like this. But I need to add the position value in details. I will directly add path here, path to, like Klaus said, join my points in the right order. Just this thing. And now I am very close to what I want to achieve. Now, I just have to turn it into a polygon. Okay. Boom. And add more stacks, because I don't have enough stack to make it gradient, and to turn it into continuous. And tada, you have a gradient area chart and curve chart in Tableau. Okay. You can imagine how much power you have now with this kind of techniques. It's pretty scary, but you feel powerful.
Okay, so yeah, this was in a little nutshell what we do all day when we create custom visualizations. And maybe to sum it up just in a few sentences, we have the drawing with numbers principle, we have the everything is a scatterplot mantra, we have data densification, we have layering, and all these techniques are around for many, many years. This is actually nothing that we have invented. You can find so many blog posts around to create this stuff by yourself. And yeah, like Ludovic said, you have the power in your hands to do such stuff like we have shown just to you. And we are quoting again a famous person, Uncle Ben from Spider-Man. Zach Bowders will be again very pleased. With great power comes great responsibility. So just be aware of what you are doing with these techniques and make sure that you choose the best visualization for your purpose and for the goal of your visualization. So thank you very much for your attention.
You,
and
thank you, Klaus.
Yeah. Thank you, Ludovic. And of course, we're open for questions. Probably on this gradient polygon stack number.
Or maybe on a beer at Data Night Out.
Okay, good. So please make sure to give us an evaluation in the app. We look very much forward to your comments on this.
Only the good ones.
No, to everyone, to anyone.
No.
And yeah, thank you for attending our session. Goodbye. See you at Data Night Out.
Bye.